All right, so you are given segment AB is congruent to segment BC. That's pretty easy. Where do you start proofs? You start with the givens. So now when you look at that, and then you look at what happens via the next step, what changed? Very good, definition congruency. What changed was that they flipped it from congruency to equality. Now remember, one of the hints that I gave you guys the other day, or yesterday, is that all of this style parts, anytime you're doing any algebra, any adding, subtracting, multiplying, dividing, whatever, when you're dealing with proof stuff, is that the segments or angles have to be in terms of equality, not in terms of congruency. Because you'll notice that all of the theorems and stuff like that are all segment addition, and you'll see that it has an equal sign. There's what is it? Additive property, equality, subtraction property, equality, all of that. That's why that looks like that. So we know that the first one was our given. That was easy. This one was your definition of congruent. Now, a lot of people yesterday when we were walking through that problem, you guys were writing out congruent. You don't have to, guys. Just put the symbol. That's what I do. And that's okay. All right? Now, what do they do here? What did they add? Segment addition. 2 smaller segments added to the larger. It's pretty obvious when it's written like that. There's your segment addition. Segment addition, there is no definition of segment addition, it's just segment addition. Okay. Now, in the next one, what changed between 3 and 4? It's substitution. They replaced BC with an AB. Like I said yesterday, a lot of times the step that you kind of overlook that shows up pretty often is that substitution step. So this next one is substitution. This next one we should have all gotten because we talked about it yesterday. What was it? Very good, very good, very good. Definition of multiplication. Now, the next one is on your reason bank. It's just the one that we haven't talked about yet. It's called the property of a symmetric property. Symmetric property states, well, actually I shouldn't say that we haven't talked about it. We actually have. You just probably didn't realize that's what we were doing. Remember when we talked about segments, that if I had a segment that was XY, we'd call that segment XY. And then I asked you guys what was the other way you could write that? YX. Because they're the same. Symmetric property allows you to write things forward and backwards. So when you see something that's been flipped on both sides of an equal like that, when they just rewrite it, that's the property. It's just a symmetric property. That's all.
So, Mrs. Thorough, Mr. Murphy.
Mr. Murphy. In case you got us confused. We don't want to put a little leaning post.
Oh, thanks.
I feel like they moved.
Your 2 lamps?
Yes. From the lamp. Sorry. I'm like the guy in Big Country Writing. He's like, smoke the Greek.
It's okay.
Oh my God. I love it.
Wow, I love my hand. That's how that worked. So when you see something that gets flip-flopped on an equal sign, all it is just a rewrite using the symmetric property. That's all. What's that? No way. Yeah, because the property itself is when you flip them across there. You see this, you guys actually do this a lot of time in algebra, you don't even realize it. Sometimes when you have like 2 equals x, you guys would say it backwards and say x equals 2. Or if you were trying to graph something, 2 is greater than or equal to x. It's easier to say x is less than or equal to 2 because now you know which way the arrows are pointing and those things. That's how that stuff works, using the symmetric property. Okay. And then, like I was just mentioning, this last one is very, very similar. Actually, this one is more similar to the example we did in class actually with the, what's it called, complementary, even though we don't have complementary. But it mirrors the same style. Now, I don't want you guys to get so absolutely hung up on every bit and piece when you're looking at it. A lot of times it's very simple to just kind of start, when you see these big long proofs with all these things going on, it's kind of overwhelming. Just cover it up as you're going, guys. Cover it up to figure out what you know. Okay? Now, how many of you guys were actually marking the diagram as you were going through this? Couple? Okay. From now on, we should make sure that we're all marking our diagrams, because that way it's going to be easier to figure out why certain things are relating to one another, okay? Well, you can start to be like her. Yeah, come on. But you can still be yourself and be smarter.
Being smarter is not always.
There's nothing wrong with it. There's nothing wrong with being the smart person in the room.
Give me one example why being smart is not good.
Well, that's mean you have more homework, classes get harder.
But you'll get a better education
I mean, that's the whole point. Okay, here's
Why are you
the
at school if you're not wanting to be smart?
I'm at school because of the law.
All right, that was good. I like that one. All right, anyway, so we've got angle ABC. The whole angle is congruent to angle DEF, the whole angle. Now, the other part of this, the next given statement for it was that angle 2 is congruent to angle 4. So I'm going to throw a double tick mark in at the 2 and at the 4. Everybody okay with that? Psst. Why don't you take out your notes or your sheet of paper that has this written down and close your computer and take your earphones out. That way we can learn how to do this correctly. Okay? Thank you. So Mr. Pitts, close the lid completely. You don't need it open. Okay? Thank you, sir. That's not what we're working on though. We're working on this packet, so you might want to find that. I know, I'm mature. I'm trying to make you learn. It's a shame, I know. Come on. What changed between those two? Definition of congruency. As you go bit by bit, that means just keep your head up too. Come on, Mr. Pitts. You can do this, buddy. Come on. We're not even the first quarter in, man. You got a long way to go. Okay? So in this case here, obviously, again, you'll notice, and it was also kind of a giveaway that was going to happen because you have all this addition and all that stuff going to go on later on. So you know that they had to switch it to that from congruency into equality. That's the rule. You got to have it in equality to make it work. So there's your definition. Congruent. What's that? Why do they change back? It just depends on what they're trying to make you show. That's all. It's one of those things that they will, when you're doing this on your own, they'll make you do that to show something else later. That comes up more into play when we get into triangles. The reason why we switch from equality back to congruency. Yes, ma'am.
So definition, congruency, and definition equal, can you switch from that one?
There is no such thing as definition of equal. It's just definition of congruent.
So you can do that whenever you want.
You use that whenever you're switching from equal to congruent, or congruent to equal. Whenever you have to switch those two.
Did you guys write that on your proof progression sheet yesterday? That would have been a good thing to put on there.
Yeah, we had it on there. Yeah. Whenever you're switching between those two. Oh, slice my finger. So the next one then, what are they saying? What are they doing there? What are they adding together? Angles. So when you add two angles together to get a larger angle, what property is that? Whoa, segment addition. Come on, knucklehead. What is it? Angle addition. Yeah, remember guys, and this a very common thing that people will do. They'll get in the rut of remembering that you've been working with segments for so long. It's all of a sudden you'll accidentally say, oh, it's segment. Remember, if you work with angles, it's got to be angle addition. Yeah, I had a little, you get those little silly little hangnail things and just got caught on something. Yeah. Of course, I get a little hangnail when I'm wearing a white shirt. That makes awesome. So both of these two put together, just your angle addition. Okay, too small or equal to large. Angle addition. Now watch what they do. Why are those two things equal to each other? So when two things equal the same thing, we say that they're equal to each other. When all else fails, what's your good guess?
Substitution.
It's substitution, guys, because you've already stated that these two angles are the same. Then you had that this one equals one of them, this one equals the other, which means these two have to be the same. That's the relationship when you work with substitution. Okay? That's how that one sets itself out. Now what they do? They didn't flip the angles. Would they move around? The 4 and the 2, because they said that 2 equaled 4 earlier, which means I can substitute in 2 for 4, because here 2 equals 4, which means this 4 can be replaced with this 2, which means it was another substitution. Hey, I bet you I know what they're going to do next. What, use substitution twice? Absolutely. Yeah?
No, I mean, can you redo that?
Okay. Going back up to this little mess here. Oops. Here we have angle 2 equals angle 4. 2 and 4. Which means anywhere I see a 4, I can replace it with a 2. Substitution. That's it. Anywhere you see when you see two things equal the same thing, you could have done it that way also. They just did it this way. This could have been 1 plus 4 equals 3 plus 4, because then you could still subtract the 4s from both sides. Here they're just set up to subtract the 2s from both sides. Yep. Because they eliminated the 2s on both sides, then into the next step. And then lastly, they flip from equality to congruency by using definition of congruency. Okay. That's how these things interrelate with one another. They just change themselves out. Most of these first style proofs that you guys are going to do, I can pretty much tell you that they're going to wind up with a substitution step, some segment addition or angle addition, a subtraction here or there, because that's how you get two things equal to each other to drop things out. It happens quite often. This scenario of how these steps work is a very common scenario for these style proofs. Okay, it is that type that is repeated over and over and over again. It's all wrong here. Let's look at the other one I wanted to look. So we've done those three. This one. So these two are, that's a midpoint. These are triangles. We don't know those yet. I'm not going to worry about those two.
What about this? We got it.
Yeah. Let's walk through the one that's backwards. Okay? Let's look at the one that's backwards. This is the top of page 3, I believe. Top of page 3. Let's walk through this one. Now, going the other direction sometimes is a little bit weird for students because they're not accustomed to seeing all the reasons. Because everything that we've done so far, you were coming up with reasons. So now you just have to think on the other side about the other stuff now. So when we start with this one, they're giving you that y, wy is congruent to x, z. So what do you think your first thing is? Not equals, but yep, wy congruent x, z. Because it's given to us. I know that's given to us. Wy is concurrent to x, z. Looking at my diagram after I mark that up, what does both wy and xz have in common? They have that segment xy together, don't they? Now, you can start to foreshadow what's going to happen because they want you to prove that wx, the small chunk, is going to be congruent to x or yz, the other small chunk. Well, just by looking at the diagram, I know that there's this common overlap. If I set this up via segment addition, I could back that out of both of them, bless you, and then I would be left with it.
So that's meaning wx is
That's how we're going to get there. But look at what their next reason is. You'll start to see you have segment addition, substitution, subtraction, but you're starting it in congruency. We have to change it to equality. So hey, this is what you were asking earlier. Can I use that definition of congruency for either one of them? Yes. Wy equals x z. No reason. No. Okay. Now, the next one, there should be a 3a and 3b because they want you to do this twice. Since we have two segments there, let's rewrite both those larger segments in terms of smaller segments. Why do we say that? Because they told you segment addition. Okay. It's just a theorem, like a theorem, postulate definition. Segment addition for us is fine. I'm not really worried about the extra added parts. So let's see here. Wy is wx plus xy, and xz is xy plus yz. I'm just using this segment addition twice to show that those two segments work out. So now I have two things that equal the same thing. What can I say about those other things?
They're equal to each other.
Very good, they're equal to each other. We've already stated that wy equals xz, which means these two have to be equal to each other. Wx plus xy is xy plus yz. What? Substitution. We have two things that are equal to each other. Well, what is wy equal to? Wx plus xy. What is xz equal to? Xy plus yz.
So you guys see you had to go back to statements 2 and 3 to figure that out. You had to go back to, oh, those two parts are equal, and then I've got my segment addition. So now I can kind of consider those two parts are equal to each other. Does that make sense?
Another way of looking at it, guys, is when you're working with the diagrams, if you look back and forth to your diagrams, you knew that this segment was already congruent to this segment. We knew that the larger segment was made up of two parts and two parts. That's all we're doing. We're putting it in a specific order to say that the two parts are also the same as the one big chunk. That's all. It's like taking a piece of paper, ripping it in half, saying it's still a piece of paper. Because it is. Okay. This should have said prop equal. Yeah. What are you going to cross out? The xy's go away. Very good. You get wx is yz. And why do we flip it back to the other one? Because it says to do so. Okay? Do the two on the back page for tonight, and we'll work on those tomorrow. Okay? Do the two on the back page for tonight, and we'll work on those for tomorrow, okay? And then I have some more of them Tomorrow we'll get into what that front page fill in the blank means, as well as trying to do some proofs completely on your own, without any of that follow through stuff, and see how it works. Okay? Yes, sir. Well, there's nothing I can do about it because I don't have to use this much battery. I've already asked for one. If it's a right angle, it just means it's 90 degrees.
Maybe I'll figure out again.